graders, we are going to be doing workbook page 122 together today. So get out your workbook page packet, a pencil, and open up your workbook packet to page 122. I think this is the last one in there. And it should say Unit 3, Lesson 13, up at the top, practice fraction operations, and should start with number 9. If you wanted to, you could work through some of these beforehand. That's what I'm suggesting in your assignment, and then double check it with me to see where you're at, but make sure that you're double checking and making changes if you get something incorrect. Okay, so it says write the answers in simplest form and express as a mixed number if possible. I have 7 divided by 1/3. I want to know how many 1/3 there are in 7. Remember, when it's division, I can multiply by the inverse, right? Because multiplication is the inverse of division. So instead of doing 7 divided by 1/3, I can do 7 times 3. Because 1/3, I could rewrite as a reciprocal 3/1. And 3/1 is 3. So 21. And think about that. There would be 3 1/3 in one whole. So in 7, it would be 7 times 3. Okay. Now number 10, I have 1 5/12 plus 2 5/8. Now you might want to have your whiteboard next to you as you work through this because we've got some work to do for this, don't we? This is addition, and this is not a common denominator right now. We need it to be a common denominator. Now this is one where if you can figure out the LCM of 12 and 8, the least common multiple or lowest common multiple, it will save you some time in the end, and it will save you from having to do 12 times 8 and 8 times 12, right? So the first number that 12 and 8 would have in common, if I counted by them, would actually be 8, 16, 24. So I would change my denominator to 24. And in order to make 5/12 24, I would have to multiply that by 2/2. And in order to make 5/8 out of 24, I'd have to multiply that by 3/3. I'm gonna put my work up here because they don't give you enough room. I know, that's my biggest complaint about these, but we'll get through it together. So this would become 1 and 5 times 2 is 10 24ths plus my 2 stays. 5 times 3 is 15 24ths. Now they're both 24ths. Yay, we can continue on solving. 1 plus 2 is 3. And then 10 plus 15 is 25. My denominator stays, so 25 24ths. Now maybe you're noticing, ooh, 25 24ths, I can't leave that. That's improper. It would not be proper. 25 24ths is actually 24 goes into 25 one time with 1 left over out of 24. And when we put those two together, now I can write my answer on the line here. 3 plus 1 is 4, and 1 24th. Piece of cake, right? I know. Just don't eat it. I know it's a piece of cake, but you can't eat it. 4/7 minus 1/3. Subtraction, we need a common denominator. And in this one, I can multiply each fraction by the opposite fraction's denominator because that is the lowest common multiple. So I would take 4/7 times 3/3 and 1/3 times 7/7. And again, I'm gonna write this little problem off to the side here, my new one. 4 times 3 is 12/21 minus 1 times 7 is 7/21. Now that they both have the same denominator, I can keep my denominator to the same. And 12 minus 7, well, I know that 7 plus 5 is 12. So my answer must be 5/21. Oh, I didn't circle my little answers. Let me go back and do that. Okay, now we have a lovely little division problem. 9 divided by 10, that means the same thing as 9 times 1/10. And if you have 1/10 9 times, that means you have 9/10. Number 13, 2/5 times 5.5. This is multiplication, right? We change this to improper. 2 times 5 is 10 plus 1 is 11/2 times 2/5. And I see that we can cross simplify. So I would cross out my 2's. And I can't do anything with 5 and 11. So 1 times 11 is 11. And 5 times 1 is 5. And that's improper, so let's fix it up. 5 times 2 gets me closest to 11. 5 times 2 is 10. And there's 1 left over out of 5. So 2 1/5 is what you should have for number 13. For number 14, 1/6 plus 2/9, we're adding again. We don't have a common denominator here, and we need one. Honestly, I would use 18 as my common denominator because that's the first multiple that 6 and 9 have in common if you count by them. If you multiply this by 9/9 and this by 6/6, you'll get the same answer at the end when you simplify it, but you don't have to do that. You can just multiply 1/6 by 3/3 to get a denominator of 18, and 2/9 by 2/2 to get a denominator of 18. So I'm going to write my new problem off to the side. I would have 3/18 plus 4/18. So see now how we have a common denominator? Yeah, so instead of 54, I can have 18. It's a little easier to work with. So when we add fractions that have like denominators, I can just add the top. 3 plus 4 is 7, and my denominator stays the same. So 7/18 would be my final answer for that one. All right, number 15. 3 1/3 minus 1 3/4. Okay, those don't have a common denominator. We need one. Let me let in my dog. Sorry. What would the day be like if we didn't have to let Millie in 800 times? Hopefully she'll leave us alone while we finish the rest of this. We'll see. Okay, so I'm subtracting. I don't have a common denominator. The first number that 3 and 4 do have in common, if I count by them, is 12. So to get a common denominator, I would multiply this fraction by 4/4 and this fraction by 3/3. Underneath, I'm going to write the new one. So we have 3 and 4 times 1 is 4, and of course our denominator is 12. Minus, there's my 1, and 3 times 3 is 9, and 4 times 3 is 12. Okay, did you see when that was a 9 and get kind of bummed out? Because you're like, oh, I'm going to have to borrow. I know, same. I feel the same way because there's not a lot of space here, but we'll work with what we have. We do have to borrow, right? We have to borrow from this 3. And when we borrow 1 whole from the 3, 1 whole when you're dealing with 12ths would be 12 twelfths. So I would have to add 12 twelfths to 4 twelfths. And 4 twelfths plus 12 twelfths would be 16 twelfths. So I'm just going to write this right in here and change that to a 16 over the top of it. If I had more room, I would not do that, but we don't. Okay, let's subtract our fractions. 16 twelfths minus 9 twelfths. Well, I know that 9 plus 7 is 16, and my denominator stays. And 2 minus 1 is 1. So 1 and 7 twelfths is what we got for our final answer there. All right. Next one, multiplication. Do you get a little relieved when you see that it's multiplication? I know. Yes, because we don't need a common denominator. We do have to change our mixed numbers to improper fractions. I had it right the first time. 8 times 1 is 8 plus 7 is 15/8. And 5 times 3 is 15 plus 2 is 17/5. Right, these are some pretty large numbers, right? Let's see if we can cross simplify anywhere. Oh, we can. This is good. The 5 and the 15. 5 goes into 5 once, and 5 goes into 15 3 times. So we do have to do 17 times 3. What I would recommend when you're trying to do 17 times 3 is to break up the 17 into 10 and 7. So you can do 3 times 10, which is 30, right? Because that one means 10. And 3 times 7, which is 21. When you add those together and get 51, that's the same thing as 3 times 17. So that's called using the distributive property. So we would get 51/8. That's improper though, right? So 8 times what gets me closest to 51? Well, I know 8 times 6 is 48, right? And to get from 48 to 51, it takes 3, and our denominator never changes. So 6 3/8 is what you should have. All right, the last one of these, I have 1/9 divided by 3, and we know that we can use our inverse to help us, inverse operations. I can do 1/9 times, this is 3/1, so if I'm going to change this to multiplication, then I need to take the reciprocal of 3/1, which is 1/3, and we get 1/27. So there's a review of basically the whole year of fractions of what we've done. We've learned how to solve all 4 operations. So now let's throw some graphing into the mix. It says solve whenever possible, express your answer as a whole or mixed number. I know, we're used to seeing those directions, right? This right here is a line plot or a dot plot, either one. It'll be called either name. We have hours slept, and there's a range here that looks like it starts from 6.5 all the way up. It shows up to 10, but the last person slept a little over that 9.5 mark. So we're gonna use this graph to answer these questions here. All right, Mr. Jones' students recorded the number of hours they slept last night to the nearest quarter hour. So it means to the nearest 1/4 of an hour. The results are shown on this line plot, aka dot plot. What is the range of values for the data? And the range means the difference between the greatest value and the least value. Difference means subtract, right? So I'm not just gonna look at this 10 and this 0 here. I wanna look at the values that actually happened, okay? So the difference between the greatest value, what is the largest or the longest somebody slept? Well, I see a dot right here, and there's not a number underneath there. But this says 9.5. We have to figure out what that dot is. It says that they were recording to the nearest quarter hour, right? So if you look here, like here's 9 and here's 10, right? There are 1, 2, 3, 4 sections between the 9 and the 10, correct? So if there's 4 sections, wouldn't that make this 9 and 1/4? And then 9.5 could be 9 and 2/4. And then this would be 9 and 3/4 and then 10. So this is just a simplified version of 2/4. So when I want to take the greatest value, this dot right here is at 9 and 3/4. Now I'm supposed to subtract from that the lowest value. Okay, now the thing is 0 is not the lowest value that happened. There was no one that slept 0 hours. The lowest amount of time was 6.5. So I need to subtract 6.5 from 9 and 3/4. That's how you find range. You do the highest value minus the lowest value. We need a common denominator for this, and we can multiply 2 by 2 to get 4, right? So let's change this 1/2 to fourths. So our new problem will be 9 and 3/4 minus 6 and 1 times 2 is 2/4. Now we can go ahead and subtract. And I see 3/4 minus 2/4. I can take 2/4 away from 3/4. It would be 1/4. And 9 minus 6 is 3. So the range of hours would be 3 and 1/4 hours. The difference between the highest and lowest values. Okay, letter B. 6 students slept 8.5 hours. So if you look up here at the 8, we see 1, 2, 3, 4, 5, 6. So 6 students slept 8.5 hours. What total number of hours do these 6 values represent? So basically it's asking you, what's the total number of hours then between these 6 students? So if each one of these dots represents 8.5 and it happened 6 times, how can I figure out the total? Well, I could do 8.5 plus 8.5 plus 8.5 plus 8.5 plus 8.5 plus 8.5. But instead of repeated addition like that, couldn't I use multiplication? 8.5 happens 6 times. So for letter B, you can do 8.5 times 6 because that's how many it happens. And we need to change this to an improper fraction. 2 times 8 is 16 plus 1 will be 17 halves times, I'm going to make this 6 a fraction by putting a 1 under it. And yeah, you can definitely cross simplify the 2 and the 6. 2 goes into 2 once, 2 goes into 6 3 times. And look at, there's that 17 times 3 again. Remember that just happened up here, 3 times 17. We already know it's 51. Our denominator would be 1 because 1 times 1 is 1. So 51 hours. So if you did a total of, okay, how many hours did they sleep all together? Yeah, 51. Okay, Olivia said the longest time value is 1.5 times the shortest time value. Is she correct? Explain. Okay, so Olivia is saying that the longest time value is 1.5 times the shortest time value. So that would mean that we could take the shortest time value and multiply it by 1.5 to get the longest. So we want to know if that's true. Well, let's try it. What's the shortest time value? On this, it's not 0. 6.5 is the one that has the dot above it. That's the lowest value with a dot. So we should be able to take 6.5 times 1.5 and get the longest time value, which is, and when you look at this, remember this was 1/4, 2/4, that is 9 and 3/4. So Olivia is saying that if we take the lowest value of time people slept, 6 and 1/2, and multiply it by 1.5, we should get 9 and 3/4. So to see if she's right, let's do this. 6 times 2 is 12 plus 1 is 13 halves times 2 times 1 is 2 plus 1 is 3 halves. And it doesn't look like we can cross cancel at all, okay, or cross simplify. So 13 times 3, then you can break that 13 up. We can do 10 times 3 and 3 times 3. 10 times 3 is 30, and 3 times 3 is 9, and 30 plus 9 is 39. So 13 times 3 is 39, 2 times 2 is 4. 4 times what gets me closest to 39? Well, 4 times 9 is 36, and 36 plus 3 is 39 out of 4. So Olivia was saying that if we took the lowest value times 1.5, we should get the highest value. And do we? We said we were trying to get 9 3/4, and we did. So yes, she is correct. Go, Olivia. All right, we're almost there. I know, this was a lengthy one. It was kind of like, looked like it wasn't gonna take that long, but then it's, yeah, a little, We'll get there. We have 4 more left down here. Check for understanding. Complete each equation. Why don't you go ahead and pause and try these 4, and then press play when you're done and check your work. All right, welcome back, or not. If you didn't listen to what I said, I won't know. But anyhow, you'll all have your correct answers when you're done. This is addition. When you have addition, you need a common denominator. And the first number that 4 and 7 have in common is 28. So I would multiply this by 7/7 and this by 4/4. And we get 21/28 plus 5 times 4 is 20/28. So we end up with 21 plus 20 is 41/28. That is improper. 28 goes into 28 goes into 41 one time. And then how many are left over? Well, you could do 28 and another 10 is 38, 39, 40, 41. So there's 13 to get to that 41 out of 28. And that is simplest form. So 1 and 13/28. The next one, it's kind of nice because do you see how they're the same exact values? Yeah, so we already figured out the common denominators, right? 3/4, we can write 21/28, but this time I'm subtracting them. So 21/28 minus 20/28. And 21 minus 20 is 1, and there is our 28th. We have the same digits again, and we're going to multiply those. So I don't need a common denominator. I can't cross simplify, so 3 times 5 is 15, and 4 times 7 is 28. And this is in simplest form. There's not a number that goes into 15 and 28 other than 1. The last one is division, and you haven't seen one like this before. But we can use what we did before to kind of help us along. So let's see how you did. We know with division, we can change these to multiplication, right? By leaving what we start with alone, because you can't change what you start with. And with the other ones, didn't we multiply by the reciprocal, by the inverse of what followed? Well, instead of 5/7, we can flip that around to 7/5. This will work. It will work. So I can't cross simplify. 3 times 7 is 21. 4 times 5 is 20. 20 goes into 21 one time with 1 left over out of 20. And that'll do it. The rest of our time we're going to spend reviewing, but we've covered all the material in this chapter. Congratulations and good luck with the rest of your work today. Have a great day.